Hi, everyone. My name is Ryan Nienhuis. I'm a product manager for the Amazon Kinesis team. Today, we're going to be talking about real-time anomaly detection using Amazon Kinesis. I'll be giving the first about 20-ish minutes, 25 minutes of the presentation. We're going to go over the context of a solution and how to easily get started, and then some high level about the algorithm. And then, depending on whether or not my partner, Alan McCannis, shows up, which I think he will, he'll present the last 10 minutes, or I'll cover the last 10 minutes, which goes into a little bit detail about the anomaly detection algorithm that's included in Kinesis Analytics. So with that, let's get started. So who here has used Amazon Kinesis before? Great. Who has used any streaming data product before? Kafka, Kinesis, Spark Streaming? Great. For those that haven't, one of the fundamental things that differentiates streaming data with batch data processing is the continuous nature of it. And in fact, most data is in fact produced continuously. So be it from a mobile app, your users are always going to be using your mobile app at all hours of the day. To be IoT sensors that are constantly reading measurements like temperature readings, humidity readings, that type of thing. Metering records, so if you have a billing pipeline and you're receiving those metering records, you're going to be receiving them continuously. The primary difference with streaming data and batch data is that we capture it and process it continuously. And for the anomaly detection algorithm that we'll be talking today, this is a real-time streaming anomaly detection algorithm. So the algorithm trains itself online. It adjusts the model online as it processes data, versus doing something in batch, maybe training the model once a day, once a week, or more frequently than that, and then loading the model into the streaming context. So the model is run, an algorithm is run continuously on data as it's produced, versus doing periodic jobs that run on various degrees of frequency. So for those who aren't familiar with streaming data, one of the primary value propositions of using a service like Amazon Kinesis, or any other streaming data service for that matter, is that it allows you to extract more value from your data more quickly. The easiest analogy I have for this is the fraud detection use case. So you are traveling somewhere, you use your credit card, you get an instant message or phone call from your bank, and the bank tells you, hey, was this a valid charge? That is really useful information. It is far less useful if you receive that a week after your trip, or a week after someone who has stolen your credit card and presented a fraudulent charge on it, and for the bank to verify it then, because the damage has already been done. So you want to get it right away. That example really demonstrates how extracting information, running machine learning on your data in real time, or running machine learning algorithms in real time versus in batch, really allows you to unlock a lot more value. So there are a certain set of requirements that you need to meet for doing processing real-time data. A portion of them are familiar. They're the same as the batch context. Durability, scalability, but some of them are different. One of the primary ones that's different is the ability to ingest data at scale. So with batch data processing, maybe you have an application server that wakes up every hour, takes a bunch of logs that were saved to disk, and then you upload to centralized data lake once an hour, maybe once every couple hours. That's a lot different ingestion path than for streaming data, where you're ingesting the data continuously, and typically much smaller pieces of data, because you're trying to react to the data in real time. So instead of getting a 100 megabyte file or a gigabyte file uploaded to Amazon S3 on a periodic basis, you're ingesting a high volume stream of events. So one event might be sub KB, maybe 1 or 2 KB, that you're ingesting tens of thousands of them, or thousands of them, or millions of them, all in real time. So the ingest part is one of the primary differences between real-time streaming data and batch data processing. The continuous nature I mentioned. The other thing is fast, the speed in which you process. So any type of processing, regardless of whether you're running a count or running an ML algorithm in real time, has to be able to keep up with the incoming data stream. So falling behind means you lose that value of doing the real-time data processing. So when we talk about falling behind, I want to make sure that I'm processing all the events as close to as they occurred as possible. So I'm ingesting them in real time, I'm processing them in real time, typically with seconds or sub-second latency. So how do I do that at scale? So a set of Amazon Kinesis services makes it easy for you. We make parallelization easy, so you can spin out a number of threads. To do so, we'll go into a little bit more detail of how the services make that easy to do. So Amazon Kinesis consists of 3 services. The first one we launched 4 years ago includes Amazon Kinesis data streams. This is core infrastructure for AWS. So it's in all AWS regions. It's used by a number of internal services like CloudWatch, EC2, as part of the backbone infrastructure of how they run and operate their services. It allows you to create a data stream that provides a temporary buffer for both writing to and reading from data in real time. So you'll set up a Kinesis stream, you'll put or write data to that stream, and then you'll set up a data consumer to get or read data off of that stream in a highly scalable, fast manner in real time. So when we talk about real time, we're talking typically around a second or less here. The primary value prop of Kinesis data streams is it allows you to choose the data processing solution of your choice. So when you get data to the stream, you can use one of our open source libraries that we provide. You can use Spark Streaming, Spark mlib on the data stream, AWS Lambda, Kinesis Data Analytics. And for the purposes of this talk, all of them have some variation of machine learning algorithms and real-time anomaly detection. We'll focus primarily on how Kinesis Data Analytics does real-time anomaly detection, but the point with data streams is you've got a flexible buffer to read and write data from, and it provides you the flexibility to use the solution of your choice. Kinesis Data Analytics is one of those choices that you can use to read data off of a stream. So you're ingesting a high volume of IoT data or application log data into a stream. You can attach a Kinesis Data Analytics application to process that data using SQL code, as well as some extensions that we have that I'll highlight today, like anomaly detection, some other ML algorithms. The way you set up an application is you create a source. In this case, it would be a data stream, your SQL code, and then what you want to do with those process results. Maybe you want to send a notification, maybe you want to store it in a database, but the whole point is that the application is operating continuously on the data stream. So as the data comes in, it keeps up in that fast manner, that scalable manner with the ingest of the Kinesis data streams. The next service that we have as part of the set of services that make up Amazon Kinesis is Amazon Kinesis Data Firehose. This service takes one of the most common use cases for streaming data, and it makes it very, very simple. I won't be talking about it much in this presentation, but the whole purpose of it is to basically get data, a high volume stream of events from point A to point B with as little effort on your behalf as possible. It solves a use case called streaming ETL. So if you're ingesting a high volume stream of events and you only want to do a simple amount of transformation and then archive it in Amazon S3 or send it to your data warehouse in Amazon Redshift, it does through that a couple clicks of a button or 1 or 2 API calls. And you've got this pipeline, the streaming ETL pipeline that delivers data at a high volume from point A to point B very, very quickly. So more specifically on Amazon Kinesis data streams. So customers use Kinesis streams specifically because it provides a very flexible, scalable mechanism to get data into the AWS cloud very efficiently. So some of the top use cases include clickstream data from web and mobile devices, change data capture from various databases, so basically getting a change data stream from, say, a MySQL database or an Oracle database and processing those events in real time. And for all of these use cases, it's about changing from batch to real time, going from hours or days latency to minutes or seconds. There's a number of tools that I mentioned. The most popular are shown on the slide here. I mentioned Kinesis Data Analytics is one of them. We're going to go through one use case today with it. Spark Streaming on EMR is another very popular option. It has provides a lot of flexibility for sophisticated use cases for those who are unfamiliar with Spark. The most popular option is listed here as custom code on EC2. We provide a couple open source libraries, the most popular being the Kinesis client library. And it's still a very, very popular option for customers to run one of these open source libraries and their own custom code just on EC2 in an auto-scaling group. It provides a lot of flexibility. perhaps more primitive APIs in Spark, but it's very, very simple and scales very, very cleanly without a lot of complexity or components. Another very popular option is AWS Lambda. So for those of you who are not familiar with AWS Lambda, it allows you to do serverless computation on a Kinesis data stream by attaching it as a source of streaming events. So as new events arrive to the stream, they're sort of micro-batched together, and Lambda functions are invoked where you can serverlessly execute your own code in your language of choice, be it Java, Python, JavaScript. The number one thing you should get out of this slide is that Kinesis data streams provide you the flexibility to build the solution of your choice. We also have a number of third-party integrations that work here, but these are 4 that are very popular. So I'll describe one use case with Kinesis data fires. It's not really the focus of this particular talk. Kinesis data Firehose, I mentioned, really solves the streaming ETL use case very, very quickly. So if you want to do things like anomaly detection in batch, and you just want to get that data and run those jobs very, very quickly, it's the tool for you. So if you're using Spark and Spark mlib, and maybe you don't want to run Spark streaming, the Kinesis data fires can get the data in the format that you need it to be in, stored in Amazon S3 in minutes or seconds, versus getting that data delivered periodically. When you use Kinesis data fires, what you do is you create a Firehose delivery stream. And that Firehose delivery stream has a number of configuration parameters, the most important being things we call buffering hints. Those buffering hints, you tell us basically a time frame or a size of file you want on S3 or the loads for Redshift and Elasticsearch, and we will buffer data until we receive, say, 100 megabytes or 500 megabytes, till we get to a nice large chunk that you want to deal with. And then we'll send it to Amazon S3 or the Amazon Elasticsearch service or Amazon Redshift. The other configurations that allows you to do encryption, compression, as well as some serverless ETL, you're able to configure a Lambda function as part of your pipeline to do basically streaming ETL. So again, for the purposes of this talk, Kinesis data fires is really about getting it to your batch analytical tools faster. I'm not sure if I keep on pressing or anything. I'm going to set it down. Kinesis data analytics. So Kinesis data analytics allows you to write SQL over streaming data, but it also includes extensions for machine learning, things like approximate count distinct, one of our own Amazon-grown anomaly detection algorithms, and some additional extended functionality that makes it easier to write SQL over streaming data. The customers use Kinesis data analytics because it allows you to solve very, very powerful use cases with not a lot of code and very simply, without worrying about some of the more complicated concepts that some of the more advanced stream processing frameworks introduce. So I'm going to cover Amazon CloudWatch because we're going to go through a use case in a lot more depth. And CloudWatch is a monitoring service. Pretty much, if you use AWS, you use Amazon CloudWatch. One of the things that it provides is an ability, there's CloudWatch metrics, which you see associated with your service metrics. You can develop custom metrics. Many of you are probably familiar with it. But there's also a service that's not used quite as often, but still quite a lot, is CloudWatch logs. CloudWatch logs, one of the things it does is it provides a mechanism to ingest log data from a large number of different AWS services automatically. So one of those is VPC, or virtual private clouds. You can ingest log data using CloudWatch logs automatically with a couple clicks that tell you API calls made against your VPC. And that's one of the use cases we're going to be covering today in a little bit more detail. One other thing that I want to mention, that some of you guys may have played around with it, a little bit related to what we're doing here. CloudWatch, over the last year, spent a lot of effort improving upon their custom dashboarding functionality. I've recently used it quite a bit in some of my demos with customers, and they're really iterating on it quite a bit, but it's a great way to do custom metrics and set up a simple dashboard with very, very little effort or infrastructure. So one other thing I'll mention on this slide. So CloudWatch logs. So the third point is one of the ones I brought up that's quite powerful. It allows you to use other AWS services as a data source. So VPC flow logs, but also AWS CloudTrail log events, Amazon Route 53 DNS queries. You can also set up your own custom logging infrastructure to send data to Amazon CloudWatch logs. It also archives your log data, and there's some analytics built into CloudWatch logs. One of the cool things you can do is you can define, using a simple processing language, define your own custom metrics based off of logs that you can then set up CloudWatch alarms for, CloudWatch dashboards. A nice feature of Amazon CloudWatch. So I bring it up in the context because we're about to go through a solution that does anomaly detection on VPC flow logs. So how do I get VPC flow logs into an Amazon Kinesis stream such that I can do that anomaly detection? So CloudWatch Logs has a subscription feature that allows you to send your logs to Amazon Kinesis or AWS Lambda directly. And this is not just VPC flow logs. This is any logs that you send to CloudWatch Logs. And you can set up filters for the description. It's a very easy way to integrate your monitoring or operational monitoring solutions with some of your more custom or flexible data processing using Amazon Kinesis. So what are some advantages of this connection between Amazon Kinesis and CloudWatch Logs? So the first is that you get access to the 3 services that I just talked to, and those services provide their own unique value set. So logging all your, having a lot of custom configurations to do archival of your log data is very valuable for doing ad hoc or interactive analysis using maybe Amazon Athena on Amazon S3. So you can set up a CloudWatch Log subscription to send data to Kinesis Firehose, and then immediately get that data into Amazon S3 for ad hoc analysis, or Amazon Redshift or the Amazon Elasticsearch service. You can use Kinesis Analytics. Specifically here, we'll talk about anomaly detection in more detail, but also any custom aggregations that you might have. So Kinesis Analytics provides quite a lot of power in the fact that you can do things like error percentages, filters, failure rates. The service implements most of the ANSI 2011 SQL standard, so you get quite a lot of power in the types of custom metrics you can compute. The combination of the subscription and Kinesis Analytics really opens a lot of doors, especially when you're trying to implement like real-time operational dashboards or trying to find needles in a haystack on your log data sent from CloudWatch Logs. For Kinesis Streams, sending data to Kinesis Streams as part of the CloudWatch Log subscriptions provides that flexibility that I mentioned. So you can use any sort of data processing framework that you want choice. In fact, you may want to do a simple data processing of, you just want to perform a filter, find a specific event, and send notifications based off of the event. And the combination of Kinesis Streams and AWS Lambda allow you to do that very easily. I guess the overall point here is that when you send the log data to Amazon Kinesis, a lot of different processing options are opened up, depending upon your use case. So how do I monitor application-specific metrics using this and Amazon Kinesis Streams and Analytics? So one of the more popular use cases that we have is this CloudWatch Log subscription, sending the data to Kinesis Streams and Kinesis Analytics. CloudWatch provides a nice agent, which is just an open source library that you can run on EC2 for logging data. It helps do pre-formatting. It deals with common log types like Apache Web Access logs. We'll convert them if you'd like them to, and then send them to CloudWatch Logs with a lot of metadata associated with them. The other thing you can do with the Kinesis Stream is do the type of more advanced analysis that I was mentioning earlier. So off of a Kinesis Stream, you can do things like, how many active users have I had over the past 15 minutes? Am I having a surge of user behavior? What are the top 10 articles read in the past 30 minutes? So if you have like a website, or what is my top page on my mobile app? So very interesting things when you, not only just operational metrics, but also product and user metrics. So I talked up the CloudWatch subscription feature quite a bit. It's one option. You don't have to use it. Another option is you can instead write data directly to Amazon Kinesis Streams. We have our own agent that allows you to write data, log data to Amazon Kinesis streams, skipping CloudWatch altogether. What's nice about CloudWatch is you get some of the features that are built into CloudWatch, like the dashboarding and the metrics and whatnot. So VPC flow logs and monitoring network activity associated with them. You can use VPC flow logs, and for those not familiar, VPC stands for Virtual Private Cloud. A lot of customers run the bulk of their workloads in them. Most of you guys are already familiar with them. One of the features that associated with VPC is a feature called VPC flow logs. And it basically logs activity in and out of your VPC. So, and you can analyze that data, network data very easily with that CloudWatch subscription by sending that data to a Kinesis data stream in real time. It includes things like shown here, a source IP address, the destination IP address, what the resulting, say, HTTP code is, whether it was accepted or a 500 error, and other detailed information about that call. So the immediate thing you can start doing is doing simple analysis on, what is my top IP address coming into the network, going out of the network, and start doing anomaly detection on that. So we'll walk through that in a little bit, but you can also do very simple analysis, just like counting the number of API calls from a specific IP address or from a specific service or from a specific user agent using VPC flow logs. So I'm showing another sort of pattern with VPC flow logs. One of the things that's sort of the nature of VPC flow logs is that they're a little bit naked. So when I say that, it's a raw log event. And you might have a lot of contextual information, such as you might know that a specific set of IP ranges are coming from this set of applications, or that this signature or user agent is a specific, coming from a specific service. So a lot of customers following this use case do perform data enrichment prior to the analysis. So in here, as part of Kinesis Analytics, you can use an AWS Lambda function to basically enrich that data, mapping IP addresses to application names to provide that little extra context. It's an optional step, but it's an optional step that provides a lot of value. The architecture diagram I have here tells you use an AWS Lambda function to perform the enrichment, and it has DynamoDB store the mapping of IP address and application names. However, you can also do this directly from Amazon S3. It's another feature of Kinesis Analytics. But prior to aggregation and getting that interesting information, it definitely provides a lot more context to the information. So the next couple of slides, we're going to sort of go deeper into the anomaly detection algorithm. I'm actually going to go back and cover it in a little bit broader detail. And I hope you guys bear with me, because I was not expecting to present these slides, but I do know the algorithm very well. So I'm going to cover it in pretty good detail on this slide, and then we'll go through a specific use case. So with Kinesis Analytics, you write SQL code over streaming data, right? And when you write SQL code over streaming data, one of the things that you do is you basically set up a materialized view on the raw data stream. So the data comes into the application, and it almost looks like you've got this continuously updated table that you're running a SQL query on, okay? So this raw data stream comes in, we map it to specific columns. So if it's JSON data, or if it's CSV data, or if it's its own custom format, we map it to basically a flattened data structure with a series of key value pairs. One of those columns based off the VPC log will be like the source IP address. If you perform data enrichment, it might be the application name. Accessible via the SQL code are a couple machine learning algorithms. One of them that we'll talk about today is an anomaly detection algorithm based off of a random cut forest algorithm. Random cut forest algorithm is our own proprietary algorithm. We do have a paper online that you can read in fairly good detail on how the algorithm works, how it detects anomalies on the stream. But as that raw data stream comes in, what it does is it takes a set of numeric data points and so n dimensions of data, and then calculates the geometrical distance of a single data point against the data points it has seen in the past. So what does that actually mean? So if you plot it on a graph, what it'll look like is for your common applications, common API calls, based off the dimensions you pass it. Taking a simple example, if you're just passing it, say, IP addresses and counts, so one key and one metric. What it'll do is it'll start detecting, is a particular IP address all of a sudden making API calls more frequently. And what this algorithm produces is an anomaly score. And the anomaly score is a numeric value that doesn't exactly match to, but kind of represents the likelihood that it's an anomaly. So when you run the anomaly detection on the stream, what we'll do is we'll annotate it with, is this specific row or record that we've seen, is it anomalous? So for VPC flow logs, the most obvious use case is doing intrusion detection using the anomaly detection algorithm. Using, like detecting DDoS attacks and things like that, using simple counts. But the more dimensions you add to the algorithm, the more accurate it becomes. So adding a single IP address count might be useful, but if you combine that with things like the counts by the destination IP address, counts by the user agent, and counts by other useful statistics, you start building a more complicated, sophisticated model, and the algorithm will take n number of dimensions. It scales very well on a high granularity of dimensions. And we'll start producing that anomaly score, and that anomaly score will tell you what is anomalous. But the algorithm goes further beyond that. The other thing that the anomaly detection algorithm does is it'll tell you, it does things called directionality and attribution. So after you have the score, what customers typically will do is they'll send it to a DynamoDB table for maybe a real-time dashboard. They maybe send a notification. So if my score is 1 or 2 standard deviations above the average, then I'm going to trigger an alarm and have somebody investigate. But when you trigger an alarm like this, I mentioned context, it being so important. So you can add a minimal amount of context, like doing data enrichment to map IP addresses to the application names. So you get some context so that when you page somebody or send a notification, you know, hey, I've detected an anomaly. It looks like this IP address or this set of applications is behaving abnormally. But it doesn't really tell anybody else any other information. So about a month ago, we added these 2 very, very additional features that tells you why the data point was anomalous. And we call those, first is attribution, and the other algorithm is called directionality. The other part of the feature was called directionality. So let's first talk about what attribution means. So attribution, based off of the n dimensions that you've passed, we will tell you what columns that you passed to the anomaly most contributed to the score. So you pass this 10 columns of various either raw data or analyzed data with like IP address counts or averages or something like that. And we'll say column A represented 80% of the anomaly. Column B represented 20%, so on and so forth. So when you send that notification out, the anomaly detection algorithm tells you this was the anomalous data point. And not only that, but these are the columns that we think are what caused the anomaly. Providing that type of context, not only just through the data enrichment, but also this type of feature, allows you to react much more smartly to it, instead of just producing a simple score. The second thing that was added to the algorithm about a month or 2 ago was directionality. The other thing that when we produce a score, what tends to happen when we produce scores is we tend to produce them clustered. So one event comes in and it's anomalous. The next event comes in that's associated with the same one, it's anomalous again for a period of time. And the reason why this occurs is the simplest example you can think is a DDoS attack. So all of a sudden we're seeing a huge influx of IP calls from this IP range, right? And when we make those calls, when we detect the anomaly, usually one anomaly gets triggered, then 2 or 3 more gets triggered before it starts to normalize. So when we say normalize, we're talking about sort of a direction. So is this the normal behavior that we'll continue to see, or is this behavior going to change over time? And this is where the feature that we added really, really adds value. And it basically tells you the vector direction of whether the anomaly is moving. So is it going down or is it going up? So is it increasing in severity or decreasing in severity? And when you're doing things like intrusion detection on VPC flow logs, that type of information is extremely valuable either to respond to programmatically or for your engineers as they respond to events. Hopefully that was helpful. It was a long-winded explanation without a lot of slides. So, so is something wrong with the network? So the next couple slides are going to talk about how the anomaly detection sort of works in a specific use case, right? So imagine you've got a set of services under a specific AWS account in a specific AWS zone, so US East 1E. And they're interacting with another account, a different account in another region. And this represents, what we think is normal behavior. And you're passing the anomaly detection algorithm a set of counts associated with this, or perhaps just the raw data associated with it. So one of the things that's hard to detect is when you look at a network, it represents a graph. And sometimes that graph is not always obvious, right? So you'll see typical behavior of service A interacting with, say, service D, but that may or may not have been correct. So when you're using the anomaly detection algorithm in Kinesis Data Analytics, one of the things that it can do is if you calculate those relationships ahead of time and then pass them to the algorithm, it can tell you when that graph changes, because it's building that model under the covers for you. So in this particular example, we're asking the question, is this a bad deployment? Did this relationship between services change? So, and the way to identify this is simple counts on these are the number of interactions had with service A and B, A and C, B and C, so on and so forth, and just enumerate those calculations. And these are very simple group by statements in your SQL code. Once you calculate those, that type of numeric data, you get some insight into building those graphs, and then passing to the anomaly detection algorithm will tell you which data points are anomalous or changing over time, what is changing about them, and what direction is changing. So changing use cases a little bit. A similar example is service dependencies, especially into and out of a VPC. So you might have a service that's housed in a VPC that's interacting with a MySQL database outside of it or a Redis cluster out of it. What are the expected dependencies associated with that service? So within the VPC, the service might interact with, say, S3, a different one of your own managed services, maybe DynamoDB, using the direct connect VPC connections that we have. Whereas you might have your own Redis cluster that's managed outside. Again, this is a use case where the anomaly detection algorithm would be doing a lot of enrichment or calculation ahead of running the algorithm will produce more valuable results. So I covered a lot of stuff at a very, very high level. There's a lot of information that you can use after this presentation to help learn a little bit more about the algorithm and the types of use cases that it solves. So the first thing is to, if you were to do anything after this talk, the one thing I would say is try out the algorithm. And the easiest way to try out the algorithm is we have this tool called the Kinesis Data Generator. It's a simple UI that allows you to write data to a Kinesis stream. And there's, in our documentation as well as on the AWS Big Data blog, we've got great documentation on going through the algorithm in more detail. My favorite one is the second one on the bottom, the real-time clickstream anomaly detection with Amazon Kinesis Analytics. In that particular use case, there's something associated with clickstream data called a click-through rate. So if you serve an ad or have a particular button, of all the users that see that ad or that button, what percentage of them click through? That particular blog will walk through the use case of detecting anomalous behavior of when this click-through rate goes up or down and what is specifically causing that. So we talked about an operational use case, but the one that I just highlight now is different in the fact that it's telling you interesting things about how users interact with your product instead of an operational use case. So there might be something interesting about why specific users connect to click on a specific button. You find that if they stay on the page and if they read the first 2 paragraphs, they're more likely to click on Get Started. Or if they stay on the page and are coming from a specific source IP address, if they're coming from Google, they usually don't click through on the button. If they're coming through one of your specific marketing activities, maybe a marketing email, they usually go through and click the button. So I bring up this simple use case because you can get very powerful insights using simple use cases like that, and getting started using the Kinesis data generator and the examples that we have are a good way to get started. So with that, thank you guys very much. I'll stay here to answer some more questions after the talk.